Assalamu alaikum wa rahmatullah. Today we will discuss another topics related to the kinetic theory. And this is molecular diffusion. Uh, Molecular diffusion related to Graham's law. So how does the molar mass of a gas affect the rate at which the gas diffuse or effuse? Okay, if you open a perfume bottle in one corner of a room, at some point a person standing in the opposite corner will be able to smell the perfume. Sorry. So molecules in the perfume evaporate and diffuse or separate out through the air in the room. So diffusion, this is called the diffusion. Diffusion is the tendency of molecule to move toward areas of lower concentration until the concentration is uniform throughout. Example, if we have a cylinder of air and a cylinder of bromine vapor are sealed together, then we have two cylinders. One cylinder is we have bromine and the other is empty and it's sealed together. So bromine vapor diffuse upward إذا راح يصير له diffuse راح ينتشر upward through the air. So after several hours bromine vapor reach the top of the column. Okay, fusion. The fusion is a gas escape through a tiny hole in its container. So if we have a container and we have a gas, so these molecule it will be escape from a tiny hole or small hole. So Graham's law of fusion states that the rate of fusion of a gas is inversely proportional to the square root of the gas molar mass. So this law can also be applied to the diffusion of gases. If two objects with different masses have the same kinetic energy, the lighter object must move faster. Because the rate of fusion is related only to particles' speed, Graham's law can be written as the follows for the two gases A and B. Rate A to rate B equal the square root to molar mass B over molar mass A. Example, if you have this example, fusion can be used to separate different isotopes of gas which cannot be separated chemically. For example, in the separation of uranium F6 238 and UF 235 the difference in fusion rate between the two gases is equal to mass of U F 235 على الماس of UF 238 وتساوي تقريبا 1.00574 which although small was enough for many kilograms of uranium to 235 to be exerted for the Manhattan Project in 1949 to produce the first uranium atom bomb, which was subsequently dropped on Hiroshima. Okay, even diffusion can be used to separate different isotopes of gas. اللي النظائر الغاز. Example 2. How much faster does helium gas fuse out of small hole than N2. So square root mass of N2 على mass of helium which equal the square root ل 28 على 4 تساوي 2.6. Okay, if you have a balloon and two balloons filled by nitrogen and the other filled by helium, so which faster the fusion? Okay, so the rate is the factor is about 2.6. Another concept for related to the fusion is the flux. It's very important in thermal physics. It quantifies the flow of particle or the flow of energy or even the flow of momentum. The molecular flux phi, which is defined to be number of molecules, which strict unit area per second. Thus, molecular flux equal number of molecules over area multiplied by the time. So the unit of molecular flux are therefore meter هو ناقص 2 second inverse. Can also define heat flux using heat flux is amount of heat over the area times time. The unit of heat flux are therefore joule meter to power minus 2 as inverse. Uh, if we have to get a result for this flux the formula, returning to the fusion problem, we know that the flux of molecule in a gas can be evaluated by integration expression 6.13 in chapter 6 over all theta and v, so that the flux equal the integral 0 للإنفينيتي dv وتساوي الانتجريشن from 0 لغاية 2 dt دي ثيتا في كوساين ثيتا ان اف في دي في نص ساين ثيتا دي ثيتا. So وتساوي n over 2 في الانتجرال from 0 infinity دي في اف في الانتجرال from 0 to باي 2 دي ثيتا كوساين ثيتا ساين ثيتا. And if you look to the integral of some useful integration to use the result for these integral, we can get the result of the flux equal 1 over 4 and the expectation variable velocity. So an alternative expression for phi can, or the flux can be found as follows. Rearranging the ideal gas law, we know the ideal gas law, the pressure equal nkbt. So we can write n number of moles equal P pressure over kBT. And using the expression for average speed of molecule in a gas form equal the square root 8 kBT over pi m. So we can substitute this expression into equation 76 and obtain the flux equal the pressure the square root the 2 pi m kBT. So note that consideration of this equation shows us the fusion rate depends inversely on the square root of mass. Okay, square root of mass because the other is constant in agreement with Graham's law. Okay, example. Uh, calculate the particle flux from nitrogen gas at STP. STP, this means the standard temperature and pressure. This means we have 1 atmosphere and 0 Celsius. So we substitute all constants and the pressure and the temperature. So temperature 0 Celsius الكلفن equal 273 Kelvin and equal finally and 180 M equal 1.01325 فوق 5 باسكال So بتساوي 13.27 متر وناقص 2 second inverse. Even if we have considered a container of gas with a small hole of area A in the side, as we said before, gas will leak. إذا راح إيش يصير عندنا leakage يتسرب or fuse out of the hole. So the hole is small so that the equilibrium of gas in container is not distributed. So the number of molecules escaping per unit time is just the number of molecules hitting the whole area in the closed box per second. So it is given by the flux multiplied per area per second, where phi is the molecular flux. This is the diffusion rate. So another example, if in the condensation methods of measuring vapor pressure, P from a liquid containing molecule of mass m at temperature T, the liquid is placed in the bottom. So we have a liquid that is placed in the bottom of container which has a small hole. We have small hole of area A at the top. So the container is placed on waiting balance, and we have a balance and its weight mg is measured as a function of time. In equilibrium, the diffusion rate is 5A, the flux multiply the area equal P fill area. So remember it's the same equation, but we multiply both sides by the area so that the rate of change of mass dm by dt is given by m phi a. Hence, now the pressure equal the square root the 2 pi kbtl over 1a times 1 over a dm by dt. Then dm by dt is the rate change of mass. Rate change of mass. In summary, the molecular flux phi is the number of molecules which is strict unit area per second and is given by phi equal 1 over 4n for average velocity. And this expression together with the ideal gas equation can be used to derive an alternative expression for the particle flux. Particle flux phi equal p square root over the pressure over the square root of 2 pi and kpt. So these expressions also cover molecular diffusion through a small hole. So this is the end of this lecture, and thank you for your attention.